Okay, good morning. Set up mechanical systems, the spring mass, write the differential equation for applying the forces. Once you are able to write the new plus four. And as I stated, the analysis time domain and required last we have seen, I believe, and one force mass and one spot. So we got you have this in your notes, or at least you can see output is considered display because that is the output and input is the applied force. Coming to this particular problem, you have two masses M2 and M1, and there is one spring and two. So hope you will be able to understand this free body diagram for mass M2. 1 4 due to the spring K, displacement X2. Force will be opposite the damping the dash pot, the damper B2. B2 is the damping coefficient because it is between two displacement, not the displacement, the velocity B2 x2 minus x1 dot. Then there is inertia force because of mass M2, always opposite to the displacement. So with these three forces shown with M2, we can easily write all the forces are in one direction, taken on left hand side, right hand side 0. Then it is uh, calculations, rearrangements of the equation, because we know finally we want the force applied is at mass m1 with a displacement x1. So finally we have the output as x2, input as f. So that always you keep in mind and open the bracket to left. You get one equation. Then come to the same this dash pot B2, which is between two. Then there is one more force dash pot with coefficient B1, but displacement x1 force M1, and that is external force. So these forces, external forward, inertia forward, dash 1 is B1 x1 dot. The force because of dash pot 2 is B2, the relative velocities x1 dot minus x2 point. form of equation, 3 forces upward, 1 forces downward. So easily you can balance the right hand and left hand side. Now open the bracket, take the just I pause here for 1 minute. You can look at the equation and let me know if any corrections are required or any confusions are there. So now this equation 3 have it variable separate. I to write the whatever is there on right hand side, entire thing divided by B2 of S. For our reference, call it as phi. Now use this phi in for x, right? Square m2 to a m1 s square b1 s b2 s. You can see that just minus x2 of s into b2 s. Okay, this is one equation. This is called substitution method. For we want x1 final equation. Only two variables. Sorry, x2s. Then the other equation is f of s. You can see the color. So take it. It's a simple else mistaken. Now we have f of s on right hand side, x2 of s on the left hand side. We want x2 of s. So you now this have these two equations. If you have pen and paper there, you can just write the equation 3 and 4. I tell you how to Kramer. This is a Kramer rule. Okay, don't worry. I will take the so same problem, same equation solving by Kramer rule. So the first which okay, f2 of that x1 s your this form you both this is coefficient of x here in this. Now, now x first see the procedure. You, I think you know this. I'm not sure. There's second x1 minus plus b1s plus and here same thing you in the later also this way. Okay. S2 m1 b in both the cases. Yes. Okay. Right. in the first. And here the like this. The elements of the matrix for x2 of s. The left hand side of most of the right hand side. My sign it is minus of minus it will become. So the values is so next you multiply those two to minus v2 sitting left top multiplied with bottom right minus sb2 minus sp2 whole square. So that again minus, it should be minus sb2 is 2 multiplied then s2 here in the denominator center this is minus sb2 you bring answer or b2s into this same answer you got in the substitution method also. And it will be clarified. I wait. You can chat with me or you can just speak to me. See some responses. This is clear. Are you there?
Guys,
You're sleeping or okay.
at least you say yes or no.
Okay. Fine.
Sir,
Thank you.
somebody is repeat.
Yeah. Anyway, repetition happens for every problem. Okay. Now I take this problem again. I will repeat the same procedure. So consider this particular. Please write down with on your notebook. Mass M1. See, problem to problem, you can see some changes. I am taking without mass, then I the mass, then I took external force. Some problems I took which are arranged horizontal direction. Some I took which are arranged in the vertical, the components direction. This problem I have taken some kind of wheel is there. Okay. I have taken this, otherwise both end it a spring and dashpot masses. Fine. Now, one thing significance of showing this wheel is that please don't consider any kind of damping between the space here. Having a the existence of the wheel or the wheel show any frictional or damping forces between mass and surface. That is the only thing. So what I said, otherwise some coefficient is not considered. You don't assume anything. In this case, don't assume any kind of. Okay. Anything I have to clear on this? Or simply you remember unless and otherwise some be don't yourself assume anything. So at least this question you can answer me. How many forces I have to show with M1? 4. Okay. Forces attached with B, force with K1, 3 convention, inertia. I think 4 will be sufficient. So F in this direction, left to right. Then one because only with displacement x will be in the direction opposite to displacement. K1. You can also take it as x. If any confusion, in x2 dot. 3 forces are over. Still we are left with one is inertia force. In one are 5 forces, not 4. For that you can consider for M independent of the relative displacement. It is only and I'll have this inertia M dot K3 then K2 this time dashpot B damping coefficient x2 dot minus dot cos 4. So just matter of writing different forces left hand side and right hand side depending upon their direction. Mass M1. So one side you can all other forces you put on the other side like this. Just a small modification in that. Variables. Same thing in the last form. Double dot become s square into x1 dot s into s like this. Same thing you can do for the other mass M2. Hope you are looking at the screen and checking whether all terms are in correct position. So open this. These are all we may commit mistake unknowingly in exam. They are not mistakes, but in hurry burry, things may go little wrong. Entire answer will go wrong. So be true. So Laplace form of that have you please chat asking me to wait. Is now come to the same equation rearranged. One equation what shown previously as x2 multiplied by all minus minus part by side of x1 of s. This is the first equation. Equation here. Take you if you want. So from this is a plus bs plus k2. So the other equation, the first equation we wrote earlier for the mass m1, that equation take yeah, so you can write it as x1, yeah, coefficient. Okay. This way you can separate. Now the value of that eliminating x because finally this only that x x a is remaining term 1 square that can as 2 now take this and after taking LCM take outside whole square bs plus k2 one equation Laplace transform s x2 of s. Okay, equals to f means this data ps k2 now those who have not understood Kramer's rule, same equation, let us try to solve using Kramer's. Then in you can choose equations. See, quantity x should be x. You should write x2 minus x1 0. This you take it as first. Second equation equated to f of s, that you take equated x2 of s term first, x1 what is you out make x2 of s here first and f. Okay, you write coefficient in the denominator. You have to write of Umesh sir. Am I audible?
You're audible, sir.
Coefficients of s, that is okay, yeah, you how to this f into c. Okay, my take. Now look at how CD values are put in of the x2 d I have written here. The C right side of it. The coefficients of x2 of s. Okay. Now to get the value, you should not be telling this to this equals 0, 0. C to this is B minus multiply A plus numerator. These two multiply as sign change. It multiplied except minus become plus. So again, same as previous answer, but absolutely simpler than substitution. Substitution, one sign change mistake or some small mistake will be carried throughout and finally you waste or spend a lot of. But this is a very straightforward. This is that is not required. This much is enough for us. Is it clear at least now? Can I see some chats? Okay. At least Riya Babu is responding to my request. Thank you very much. Okay. Some more? Sibin, thank. Okay. Sir, is it time?
9:35.
Last problem for this class. Look at this 8th problem. Again, small. Ask him to reading the problem, because if you are writing, giving time for you to write, I'm explaining this, then there is now free body diagram and all not required. Directly you can write the differential equation, but in exam you don't skip. Here directly I would like to write for x1 double dot b1 has plus minus x2 dot x1. This is one equation. Take Laplace time. Then one s what separating the variable. This is having x1 of s, 1 of s, and even this rest all are x2. So I have shown color x1 in one color. Now that will give you all one. So you make it equals to our data. Let us see. Call it as 1. For mass M2, can you directly write now? Force, rest all the forces will be acting in other direction. So force applied, all the other forces, take the Laplace transform, separate the variable in minus x1 of s See, I am trying in the F1 here. The output in this problem. The displacement is already applied for. Input is this. So in earlier problem we used to find x2. Now in this problem, x1 coefficient is written in the first place. 1 and 2. Okay, 1 x2 is next. But our way of writing the Kramer's rule is same. Okay. So take these two x. So your x1 plus x2 the same as here is in both the cases. Like I said 0 and f in denominator square ps plus k1 ps plus k1 here. The, so this is how you get x1. Other things are same. Multiply these two, you get these two. If you multiply 0, this will be minus into minus plus square. Oh, equals to oh, this here. Then f of s, you can bring it f of s k1. Yes. You will see more problems. Any doubts?